Now, if you look at the sequence, that we're given, all right, we could try and test out and see, is it arithmetic? Is it geometric? And what happens if it's not? Then we've got to use a little bit of creativity. All right, is it arithmetic? Right, that means the common difference here would be, let's see, -1, what do I need to get to give 2? I'd have to add 3, and it would give me 2. And then if I add 3 again, the next term should be 6, and it's clearly not. Right, so it's not going to be an arithmetic sequence. That's no good for us. Right, so that's out. All right, now, the multiplying factor or common ratio, if it were geometric, let's see, what would it be? It would be 2 on -1, -2. But if I go to the next term, let's see, what would it be? -3 on 2, -3 halves. They're not the same. So it's not arithmetic, and it's not geometric, which means we can't use our 2 standard formulas for the nth term in order to calculate what the sequence's general term is. It's not our 2 standard ones. We've got standard ones we can work with, and what happens if it's not standard? Then we've got to get creative. All right, so now we're going to try and be creative. All right, here's our first one. Here's our second one. Here's our third one. This is the 4th term. This is the 5th one. All right, this is how we started out. Before we talked about arithmetic sequences, before we talked about geometric sequences, what do we do? Can you see the pattern? Here's the first term, there's the same number. Here's the second term, there's the same number. There it is there, the same number. But of course there's a negative sign there. We can deal with that in a minute. 4, 4. 5, 5. Alright, so what is it saying? If I want to calculate further on here, what would the 10th term look like? Well, I don't know about its sign yet, but I do know this, it'd have to contain the number 10. It must contain the number 10, because there's a relationship here between the numbers. Alright, how would it go? Negative, positive, negative, positive, negative, positive, negative. It looks like when it's even here, right, the number happens to be positive, so I can be assured it would be a plus 10 for the 10th term. But the question says, work out the general term. The general term. Alright, so what does it look like? Okay, for n equal to n, let's see what we've got. N is 5, there's the number 5, 4, 4, 3, 3, 10, 10. Alright, so it must be n is the relationship. N, 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 n. Now, how do we deal with the sign? How do we deal with the sign? Let's see. The first term's got to be negative, so it looks like when it's odd here, it's negative. When it's even, it's positive. So we try something. Only -1 changes sign with a change in the power here. Alright, so when negative when the power is 1, we'll get -1 to the power of 1, which is -1. Alright, so here we need -1 raised to the power of n. Let's try it out and see. A1, what would it be? -1 to the power of 1 times 1. -1 times 1. -1. Is that what we got? Yes, it is. Try the next one. A2. Alright, so I'll do that over here. A2. What should we have? -1 to the power of 2 times 2. That's 1 times 2. 2. And it's positive. A3. -1 cubed times 3. -1 times 3. -3. And yes, it works. Alright, so here, this part was easy to get. The number to match up with the term number. But here, to introduce the alternating sign, you need -1 to the power of. Alright. And then you put the two together. here, the term number, here, the alternating sign, and they just come together. But you've got to look for it. Okay, now, the next one.